Hello, my name is Rakaya Fletcher. Welcome to Tech Tuesday at 2 in the Edmund Lowe Creative Studios. Both the event and this space are designed to encourage students to experiment with some of the latest software and devices. We want to make these tools accessible to all OSU students and provide opportunities for students to develop proficiency and comfort with the kinds of technology they will need to be successful at OSU and beyond. Tech Tuesday at 2 will meet here in the Edmund Lowe Creative Studios on the first Tuesday of every school month for interactive showcases of emerging and innovative technology. Last month, we learned about the green screen and Chroma King. If you missed one of our programs or simply need a refresher, all of these programs are rebroadcast on O-State TV and can also be found by searching the library's website for Tech Tuesday. Today, Shannon Gard, technology specialist here in the Edmund Lowe Creative Studios, will take you from model to prototype, starting with a hands-on demonstration on how to model for a 3D print, followed by an overview on how to print your creation using one of our 7 3D printers here in the library. If you're watching on today's live stream, you can submit questions via Twitter or Facebook using hashtag LibTech2s. If you are here in our audience, you can ask questions at any time during the presentation. The green sticky note on the back of your computers indicate I'm good to go and following along. Place the pink sticky note to indicate you have a question or we'll be gladly to swing by and help. At the end of the program, we'll be drawing for prizes, including today's grand prize, a 3D doodler, which lets you draw in 3D space. If you're an OSU student here with us, be sure to fill out a prize entry form. Now I'll welcome Shannon Gard.
Thank you, Rakaya. Okay, for those of you who don't know me, I am Shannon Gard, and welcome to the Creative Studios. So as she mentioned, here in the studios, we provide the technology that people can use to be successful in whatever academic or creative endeavors they might see fit. So let's jump right in. So how many people here have ever had an idea or wanted to get some prototype of something or a product and you have no idea where to go to? Couple, okay. Well, in the old days, I say in the old days, it's still this way. For the most part, if you've got an idea for a prototype, a model, a really awesome pencil cup, or any of this other things that I have up here, your resources were somewhat limited. Your options to get an actual idea from paper to model to actual printed object were limited to, you had to, well, let's go into it. Your options were limited because there weren't many technology advancements available that were affordable. So these days, you've got a lot more options. So first of all, you could go through a third-party company. There are tons of them out there whose sole purpose is to go from models to pre-production prototypes. And they do this by charging you thousands of dollars and taking weeks and weeks. And believe it or not, they call this rapid prototyping. And I'm not downplaying what they do. They do a wonderful job and they're great for, major innovations and ideas, but that's not feasible for someone who's just got an idea that they just kind of want to see come to fruition, or just something in their environment that they want to augment or hack. So they would use traditional methods like CNC machining. They would use injection molding or urethane casting, all sorts of cool methods. But again, it goes back to availability. You had to pay them a heck of a lot of money, and you kind of had to already know what you're doing. And even then, I've heard horror stories of people that send off to get, 100 prototypes made of their new innovative idea, and it comes back wrong, and they've just spent thousands of dollars and months of their production time working on this, only to have to start back all the way to zero. Your second option, obviously, is I know a guy. He's got a shop, he's got a CNC machine of his own, he knows the tools, and you go to your friend and you say, hey, I know you're busy, but ... And then there's always the third option, which most people shy away from because it can be difficult, which is make it yourself. This is what I'm all about. With the onset of 3D printing and open source software and online databases to get you started, there's no reason that you can't make these objects and ideas and even just simple everyday things by yourself. You don't have to go through a huge company. So let's jump right into digital resources. Now, I'm a big fan of open source software. Vis-a-vis Blender is open source. It's made by a company, I don't even know if can you call them a company? Whatever. They're out of the Netherlands, and it's a consumer and customer-driven, crowdsourced type of software that does 3D modeling that anybody can learn. And I normally would, if someone says, oh, anybody can learn it, it's usually just them saying, I've learned it, anybody else can. I honestly mean it, because over the past 2 years, I've taught over 300 people who have no prior experience with 3D modeling how to use this software from all backgrounds. You don't have to be an engineering major. I've taught everybody. But there's a lot of different computer-aided design or CAD softwares out there, but they cost thousands of dollars a month, and unless you're in these engineering programs, you're not going to have ready access to it. There's SolidWorks, AutoCAD, I almost said Blender, Rhino, Maya, the list goes on. Google SketchUp, there's a good one. But again, most of these software are very difficult to learn unless you've taken a course. They're really complicated and they're really expensive. And nowadays, it's not enough to just buy the software. It's a $1,000 a year subscription to this stuff. Again, why I like Blender. Okay, I'll stop harping on Blender. Next is if you don't want to model it yourself. Not everybody has time to design something from scratch, even though it can be fun. Sometimes you just have an idea for an object and you just want to see what it's going to look like. You want to put it in your hand. This is where databases like the Thingiverse, love the name, and GrabCAD, another good resource. There's a ton of them, but these are my two favorites. Sometimes you just want to get an object and play around with it. There's other resources out there. This is the Curiosity rover. I actually got this file from NASA, but a lot of the things that I have on here were just things that I've downloaded and then printed out. So let's go a little bit deeper into Blender first. So here's your perks. Open source, aka completely free. There's a ton of tutorials on the website themselves, which I should have put on here, which is blender.org is where you can obtain this software. And the best part also, aside from being free, is it's crowd supported. If you've got a problem or you can't figure out how to do something, it's as simple as a Google search. I can't figure out how to ... and there's 50 other people that have had that same problem, and it's in a forum. Cross-platform compatible. So if you're a Mac user, PC, Linux, if you're a crazy person, it works with everything, which is also great. And I've got a nice little demo here. They put together demo reels of user-submitted content every year, and so far the 2015 is my favorite because I should mention Blender is a very powerful software. It's not just for modeling. It supports the entirety of the 3D platform, so you can add textures and rendering and lighting and gravity and environmental factors. So all of this that's in this video is stuff that just users have submitted on their own. I hope this isn't loud. And the best part, one of my absolute favorite parts about Blender is that not only is it open source and free to develop and augment and even adjust the code if you like. They offer the code for free to anyone who wants to augment it, and then you can even sell the software if you've made a nice augmentation. Nobody really does because they love that it's open source, but anything that you create in Blender is your intellectual property. You don't even have, like, if you made one of these videos and you ended up, I don't know, selling the product or having that be an advertisement for Starbucks or whatever, you don't have to even mention that you use Blender. They don't want any credit for anybody's work. But again, this software is pretty powerful. It does everything, but what we use it for is pretty straightforward, and that is the modeling aspect. Yay, roll credits. All right. Okay, so that's a good resource for your own modeling. Next up is Thingiverse. Thingiverse is actually an offspin of MakerBot, which is the manufacturer of 4 of the 7 printers that we have here in the studios. The Thingiverse started out as just a small repository for people who had their own designs to upload, and share. They wanted to show people what they were doing. Now it's turned into a gigantic database of all sorts of objects. If you're looking to, say, for example, print that just fell right out there. If you're looking to make a pencil cup for your desk because you just you can see a different kind of augmented version of it there. You can literally just search pencil cup. If you need a hook to hang on your wall because you can't drill any holes, you can literally look up hook and you can find a whole bunch of these. This hook I got off of the Thingiverse, and I messed around with it, resized it because I needed to be smaller than what they originally had, and this took me about 30 minutes of print time and about 2 cents worth of plastic. Not that we charge for filament, but as opposed to getting in my car, going to Walmart, finding a pile of these when I only needed the one, buying a $10 pack of these, figuring out what to do with the rest of them. I could do all that, or I can just push the print button. So this is kind of what we're going to get into today. The other resources, GrabCAD is another really good one. This one's a little bit more engineering heavy. This one deals with machinery, parts, engines, gears, anything that mechanically moves. Another great resource. So those are some good digital resources for the model if you want to model yourself or if you want to just grab something offline. Next up, go into the actual prototyping. So you've got your model, you've got your whatever. In the studios, we have, as I mentioned, 7 different 3D printers, all of which are available for anyone to use. Bless you. We have a certification process. We will teach you from start to finish how to work with these machines, and I made a little time lapse here. My intern, Luis Farias, spent a large part of last semester making this beautiful model of the Edmund Lowe Library. I'm very proud of him for that. Before that, before we made the big version, we kind of wanted to see what it did. So here's you a nice time lapse of this on one of our printers doing the thing. This took about 20 minutes, and here's your finished product. There's you a nice little, yeah. So from model to prototype, this is what it's all about. Those companies that claim to have rapid prototyping, this is rapid prototyping. This is hyper prototyping. Going from an idea to an actual physical object is something that we just haven't had, not until this technology became more readily available. So these are the people you'll be working with, myself, and this is Luis. This is him sitting proudly with his design here. And I should say, the software that he used wasn't Blender. He used a software called SolidWorks. But that's the thing. It doesn't matter what 3D modeling software you use. They're all compatible with 3D printers. Yeah, he's cheesing pretty hard there. Okay. So next up, the process. How do you get access to these machines? I have one hoop that I make everybody jump through. You've been through it, this guy. It's pretty straightforward. Using whatever 3D modeling software you're comfortable with. If you're not comfortable with any, that's fine. Shoot us an email and we'll give you a quick crash course in Blender. It's very straightforward to use. But you will create a simple object via a keychain using basic objects, and you can use Blender, you can use Maya, you can use AutoCAD, SolidWorks, whatever you prefer, and you're going to save it as an STL file. STL is the standard universal 3D printing format. It's like the PDF of 3D printing. And every 3D modeling software can export in it somehow, some way, usually save as STL. Once you've got your keychain modeled, or if you don't know how, once you've talked to us and then we've shown you how to do it, you'll email us requesting a time to sit down with myself or Luis to get certified to use these printers. We show you all about how to import your model, how to rearrange it on the build platform, how to check the settings and make sure all the, there's different factors that can contribute to a successful print or an unsuccessful one. We show you how to do all of that. We walk you through the process. And the assessment takes about half hour-ish. And as I said, we've certified over 300 people from all backgrounds, so anybody can do this. So everything that you'll need if you want to either take notes, email yourself, or create a note, whatever, from start to finish. Some modeling software. I recommend Blender. I'm very biased. What can I say? Thingiverse, GrabCAD, great resources for finding objects or inspiration. Our email is lib-res@okstate.edu. And now we're going to get on to the actual kind of interactive part of this. I want to show you guys how easy it can be to go from a model to a prototype. But before we get into that, does anyone have any questions thus far? No? Awesome. Okay. All right, well then let's dive right in. On your laptops in front of you, go ahead and open up Mozilla Firefox, and we're going to start with the Thingiverse. I'm going to show you all the awesome, and the server's not found, things that are on here. So once that pops up, we're going to take a look at what we've got here. They always have featured items. Sometimes they're made by the engineers and the lab rats at Thingiverse themselves, or MakerBot in the company themselves, but this is so much user-contributed stuff. Everybody up? Yeah. And I should say Thingiverse, it's spelled thingiverse.com. Thingiverse just sounds odd. Okay, so once you're there, to kind of jump start it and just get down to the databases, go up to where it says Explore and Things. It's very specific. Now what you're going to see first of all are the most recent items that have been updated. What I like to do is under Explore here, drop this down to Popular. This is where you're going to find the most common and honestly some of the coolest objects. But what I'd like you to do is browse around and look for something that catches your eye, because all of this can be downloaded for free, imported into MakerBot software, and turned into, ooh, headphone stand. Okay, I'm going to find something small. If you want to arrange by category, be my guest. I like practical items, so I'm going to go for household. Let's see. So we got a lamp. Ooh, that's cool. Battery holder. Could use that. I'm big into plants, I'm not going to lie. This model here with the this blue object, I made one very similar based on its design. I'm a big plant nut, but these types of plants have to be watered from the bottom, not the top. So using that design, I made my own watering device for this plant. So anyways, that was loud. So once you find an object you find interesting, let's go ahead. You know what? I'm just stuck on that headphone stand. I'm going for the headphone stand. Click on whatever it is. Get a good look at it. See if it's something you'd be interested in. And you're just going to go to Download All Files. And if you're having trouble picking, don't be too picky. There's a lot of really cool stuff on there. So pick the first thing that catches your eye. You're going to want to save the file. And you can put it on the desktop. You can put it wherever. Now it's going to be in a zip folder or a zip file. You'll have to open it up and copy the files and put them somewhere because the software doesn't like to open directly off of a zip file. Nothing does. So once you've got it downloaded, you're going to want to open it up, go to where it says Files, and find the STL file. Now you can grab the .MakerBot file. Those are projects that are like ready to print, but I like to play around with the settings a little bit, and I'll tell you what I mean with that. So here's my STL. I'm going to copy that, and I'm going to just put it on the desktop. Paste. All right, good stuff. So once you've got that done, just let me know. If you're not quite done yet, let me know. If you're having trouble, you good? All right, good man. All right. Okay, so I've got my file. You got it? You good?
It's multiple STLs.
Okay, just pick one. It's okay. Yes, ma'am. Is it not? Can you check that zip file? Thank you, Cody. Did you get one downloaded?
It's one to open through.
Okay. Yeah, don't try to open the file. I should have mentioned that.
My bad.
I mean, you want to export the STL file, but don't try to actually open it. To moving ahead, what you're going to use is the software that's installed on your system called MakerBot Print. It's on the desktop. Just click to open that. All right. When you get to this step, let me know. Good? All right. Excellent. You guys got it open? Brilliant. All right, so what you're looking at is a nice representation of the build space of this MakerBot Print. This is a good jumping off point. Let me get myself warmed up here. So what you're going to do, the way you rotate around, by the way, is by holding down right click so you can kind of see it from all sides. So click this folder button right up here in the corner and go to Add Models and navigate to where you saved your model, whatever it is. In my case, it was on the desktop, but MakerBot headphone stand, awesome. Whoa, that's huge. Okay. That's okay. That's okay. Everything looks huge at the outset. It looks like it, but it's really not. Take this into perspective. There you go. Okay. So once you've got your object imported, the first thing you're going to want to look at is how it's arranged on the build platform. When you think in 3D printing, you've got to think from bottom to top. Now I'm kind of jumping ahead and just kind of giving y'all a quick crash course, but this is perfectly aligned to print, but if it was, say, oriented like that, that is a terrible way to think about printing something. With a 3D printer, think of it as building something with a hot glue gun. You know, you're laying down layer upon layer upon layer, and if something is poorly arranged, it's just going to turn into spaghetti. It's not going to print very well. So this panel over here on the right-hand side is going to be your best friend. Using your rotation button here, you can hit plus or minus 90 degrees and get it arranged to where it would print in an ideal way. You can also grab the object and move it around on the build platform. This is honestly way bigger than I think I would actually need it, so I'm going to resize it. This first button down here on the bottom is for scaling. Scaling, you can just go by a percentage. I'm going to make this at about half size by just typing in 50% over on the scaling. So now this looks like a much more manageable size. That looks pretty good. So yeah, that looks about right. I should mention, on yours, you may have to add a printer to it. Down here at the bottom, this pops up, you want to hit add a printer. Lower right-hand side. And you're going to go to add an unconnected printer, and we use Replicator 5th gens. But that's not crazy essential. So once you've got your object arranged how you'd like it, then let's find out what this will actually take. Let's say this second from the top here is to get an estimate and a print preview of what it is that you're going to print. So just click that, and that'll start rendering it and finding out how long it would take to go from start to finish for this object, whatever it may be. Does anybody need a hand? All right? Okay. All right, lovely. Okay, so I've got a nice preview here. And we can see from start to finish, this headphone stand would take 2 hours and 22 minutes to print. Everybody see where I got that? The main view is this one here at the top. To get it rendered, once you've got it arranged how you like, this is your preview button. And once that thinks a little bit, it'll show you what it's going to do layer for layer from start to finish. So if I were so inclined, if I desperately needed this headphone stand, it took what? All of 2 minutes to find something online, and that would take all of 2 hours to print. So this is what I'm talking about with rapid prototyping, or I should say hyper prototyping. The big gains from this are they become apparent more and more as you go on. We've had these 3D printers here in the library for about 2 years now, and they've been used for an amazing amount of different purposes. We have had people in here making housings for Raspberry Pis. We have had people in here building skateboards with motors in them that they designed themselves. We've had people in here printing out chess sets. We don't judge. The only stipulations for our 3D printers are that you get certified and learn how to use them. The printing restrictions aren't many. We try to keep it under 8 hours of build time just to keep it fair. But everything from teaching tools to just personal hobby items. This is one of my favorites. We had some design, housing, and merchandising folk in here a while back that used our printers to create wearables. This is a bracelet that was originally printed flat, but because it was so thin, she was able to bend it around and turn it into a bracelet. I asked for a copy because it's as simple as hitting the print button. This took all of about 10 minutes to print. There's so many different possibilities. When this type of technology is available to you and when you see what it's capable of doing, the possibilities are endless. And I really mean that, even though it's a kind of a cliche. So in truth, that's really all I've got thus far. If you're interested in getting 3D certified, I have information up here that you'll need for getting in touch with me or my intern Luis. If you have questions about the 3D printing or modeling process, you can come in and talk to us anytime. Our office is in 105. And again, this technology is here for you. It's here for you to use. It's here for you to experiment with. It's here for you to get experience with. And it's free to use. There's no cost for the filament. And I love seeing the different ways that people use this technology. So thank you all, and I'm going to turn it over to Rakaya. Appreciate it.
If you want to know more about modeling, 3D printing, or the equipment available here in the library, I encourage you to visit with our knowledgeable staff in the MLO Creative Studios or check out one of our logins for lynda.com, which offers thousands of online training videos on a number of topics, including Blender. Our next Tech Tuesday at 2 will be digital story mapping. This will be held on November 7th, and we hope you all can join us. And as always, we'll be giving away some great tech prizes to our student attendees, so be here for a chance to win. Also, I want to mention the Library Creativity Award. All OSU students will have a chance to showcase their creativity and win awards in 2D, 3D, motion, wildcard, and best in show categories. You can visit our website or ask any of the event staff if you'd like to learn more. If you have any suggestions for future Tech Tuesday at 2 topics, please send them to us with the hashtag LibTech2s. Right now, we're going to say goodbye to our live audience before we draw for prizes. Thank you to our friends at O State TV for hosting today's live stream, and goodbye to everyone online with us today.